Welcome to this video. And in this video, we're going to talk about slope-intercept form of equation of a straight line. Okay, so we're doing equation of straight line series. And in the previous video, we have learned how to find the equation of a vertical and a horizontal line. Okay, so if you have a vertical line on a Cartesian plane, on a xy plane, then the equation will be equation of vertical line will be x is equal to something. Let's suppose that is a. Horizontal line, y is equal to b. Okay, so it is parallel to the x-axis, and that is parallel to the y-axis. We already have talked about this. If you want to get this in deep, then please watch my previous video, which is here, okay, on the I button. So click on the I button to get that. We also talked about what is slope in the previous video. Okay, so moving on. In today's video, we're gonna talk about slope-intercept form of equation of a straight line, which is, so first should I, okay, so I should not give you the form, what the form is. Actually, let's do it from scratch. Let's derive the form also. Okay, so it looks straighter than previous one. Okay, so you have a Cartesian plane over here. And as its name suggests, the same said slope-intercept form, meaning we're gonna have slope known there and the intercept known there. Okay, so then you need to find the equation of the straight line. So how do you compute that? Okay. So let's start with the intercept here. Okay, so we're gonna derive this from scratch, the form also. Okay. So you're gonna have either the x-intercept or y-intercept given. Okay, so let's suppose that we are given the y-intercept, because in most of the case we deal with y-intercept, and y-intercept is given. Okay, so let's suppose the y-intercept is given. Y-intercept means where the straight line cuts on the y-axis. Okay, so let's suppose the straight line is like this. Okay, having a positive slope. Okay, so if you have this kind of inclination, it's a positive slope. And let's suppose the y-intercept is here, and that is, let's do it by me, because we're doing algebra right now. Okay, we are deriving something. Okay, so this y-intercept is b, meaning it's coordinates. Pay attention, audience. If you have any problem with this, tell me. Okay, so the y-intercept is b, so its coordinates will be 0, b. Got it? Y is coordinate will be this. What is it on the on the x-axis? It's 0, moved nowhere. What is it on the y-axis? It's moved d units above the origin. Okay, so it's the y coordinate is b, x coordinate is 0, so it's 0, b. Okay, the coordinate of this. So you have the y-intercept here, which is b, and the coordinates of this point is 0, b. Okay, perfect. Okay, so so we know the intercept. Now the next thing that we know is the slope. Okay, and then we want to find the equation. Okay, so next thing we are given is the slope. So pick any point on the straight line. Let's suppose we pick this. Okay, why picking it? To make the generalization, which will be true for any point on the straight line. If you're not getting what I'm saying, you'll get it now. Okay, so I suppose the point is x, y. So I suppose in terms of variables, because this should be true for any point on the straight line, or I'm deriving it, making it generalization. That's why I'm using algebra. Okay, now let's compute the slope, which is here. Okay, so it'll be changing y divided by changing x. What is changing y? It should be b minus y, as you already have it. Let's add it here. So and will be slope here will be b minus y, changing y. What will be changing x? Very good. Now, moving further, you're gonna have b minus y minus x. Okay, if you take it onto that side, it'll be minus mx is equal to b minus y. If you compute for y here, because I should have written this cleanly, but as I'm running out of space, I write it here. Okay, but you're getting my point. Okay, so if you want to note this down, you can also note it down. Okay, y will be what here? If you bring it over that side, then y is gonna be mx plus b. Right, so y is gonna be mx plus b, and this means is the equation of a straight line. You'd be like, you would be like, I'm not a how you have the equation of the straight line, how you came up with this. Like after all of these steps also. That We did nothing else. We had this intercept given here, so the y-intercept given of the line. So we wrote our y-intercept, and the next thing we picked up any point on the straight line. You could literally pick any point and name this x comma y, meaning it is true for any point. Okay, then the thing that we're naming it x comma y is that it is true for any point on the straight line. And the thing we will have is a generalization, and this is what equations do. Equation is generalization for the straight line, or something that tell about the straight line, okay, or indicate the straight line, or shows the straight line, okay. So we had given the m, meaning the slope. That's why you computed slope. If we already had the slope, then why you computed it? Because to derive it. This m is gonna be already with us, meaning the m will already be computed in there, okay. And that is the slope-intercept form. Y is equal to mx plus b. How you derived it? This is how we derived it, okay. Okay, so now you have the equation of a straight line in slope-intercept form, which is y is equal to mx plus b. M is a slope, b is a y-intercept. This is a constant, this is also a constant, this is a variable, and this is also a variable, and this shows the relationship between x and y, how x and y change. And this is what equations do. Okay. That was using the y-intercept. What if you use the x-intercept? Let's find out. What if you use the x-intercept to compute the same equation? What's the time? Can anyone tell me? It's 10:45. What if we use the x-intercept? We already have seen that if you use the y-intercept, call it b, then the equation is as follows. Y is equal to mx plus b, where m is the slope. What if you use the x-intercept? Let's find out. Okay, so let's find out. Same Cartesian plane. This time we're going to use the x-intercept. Let's suppose the intercept is made here. Okay, the line goes, okay, just like this. We're going to be perfect, but yeah, you get my point. What will be the coordinates of this? Okay, so let's suppose the x-intercept. This thing, we need the length of this thing is a. Okay, so I write this x-intercept as a, meaning wherever it cuts the x-axis, it is a here. So it's going to be a comma 0. You know how it's going to be a comma 0? Yes. Because it's on the x-axis. At a, it is at a. So on the y-axis is moving. Nowhere is sitting at the origin. So it's a comma 0. That is coordinates and the x-intercept. Now the next thing we are given is the m, meaning the slope. So let's take any point here, which is gonna be in terms of variables, and from here we're gonna derive the equation. Okay, x comma y. Again, I'm iterating y, letting it be x comma y, because it's gonna be a generalization. Algebra is all about generalization. Okay, coming with equations which fit for all the points on the straight line. It's gonna be m is gonna be what here? Change in y, which is y itself, y minus 0. You can go in that way also, 0 minus y. But if you go in that way, then you also have to go in x in that way. Okay, and here x minus a, because you subtracted this from this, so this also. Okay, now this will be y is equal to m times x minus. M times x minus a. Okay, so this is what it will be if you do it with the x-intercept. A represents here the x-intercept. Okay, so this is the equation of the straight line. If you go with the x-intercept, we're gonna have the slope here, and it will be y is equal to m times x minus a. Okay, so let's note that here. Y is equal to m times x minus a. Okay, all right, we are done now. So using y-intercept, we have this equation. If you use x-intercept, we have, okay, meaning a, x-intercept, we're going to have y is equal to m times x minus a. That is going to be an equation if you use the x-intercept. Okay, note this down, and also I suggest you to actually note the proof also, which I had showed you earlier. Okay, write down the proof also. Okay, so now it's time to give you some examples. So, okay, but the most popular is this one. Remember this, okay? The mostly used is this one, using the y-intercept. You may also have, the x-intercept given to find the equations. Sometimes, but mostly y-intercept. And let's give you some examples. Some examples of straight lines or equations of straight lines in the form of slope-intercept form might be y is equal to 2x plus 3, where 2 here is the m, meaning the slope. Slope is 2. B, meaning the y-intercept, is 3 here in this case. Okay, so it's a positive slope, meaning it goes that way. This line will be something like this. Okay, so this is not the perfect drawing. It's not the perfect line, but I'll show you the slope, how the slope would look like or go. Okay, now let's compute the straight lines if we have the necessary conditions given. Okay, so let's do an example. So if we have, let's say, slope already given, which is, let's say it is 3, and the y-intercept is given as, okay, so enumerate fully, y-intercept. If the y-intercept is given as 3, let's make it different number. Let's suppose this is 4. Then this equation will be y is equal to arrow x, meaning m is 3 here. So 3x plus b is here 4. So this equation will be this. Okay? And in that way you can write the equation of any straight line given m and the y-intercept. If you're not given the m and given 2 points, then derive the m using 2 points. And you need to have given the y-intercept. If you're not given the y-intercept or only given the 2 points, then actually it's a different form. Okay, which we'll talk about in the upcoming videos. What about x-intercept? Okay, when you're given, let's say m is given as 2, and x-intercept is given as x-intercept. X-intercept is given as a is 3. What will be this equation? It will be y is equal to, what's the equation when you have x-intercept given? Can you remember that? Can't? And it is m times x minus a. Should memorize them all. Should memorize it. Okay? So y is equal to m times x minus a when you're given the x-intercept. M is here 2, and x minus a is 3. This is going to be the equation in which form? In slope-intercept form, if we have the x-intercept given. If we further simplify this, then you know you're going to have the y-intercept, in the form of y-intercept, okay? Meaning 2x and minus 6. This is the y-intercept, this is the slope here. If you simplify this, you're going to have the y-intercept given. And this is the reason why we mostly have the the straight lines in the form of y-intercept, not in the form of x-intercept, mostly. But you should learn them both. Okay. Now let's learn how to graph a straight line if you're given this equation. Okay. Let's learn that now. How to graph the straight line. Let's say you're given an equation y is equal to 2x plus 6. You want to graph this. How you can graph this equation on a graph paper? Okay. Or on the xy plane or Cartesian plane. Okay. In order to graph it, you need to write the m and the y-intercept. M meaning the slope, which is 2, y-intercept, which is 6. Now, from this, you might have already known that the one point which lies in the straight line is the 0, 6. Okay. So 0, 6 will be, let's say it is there, 0, 6. And that's going to be the y-intercept here, which lies on the straight line, okay? Because it is the y-intercept. This is where the straight line cuts the y-axis, okay? From this, I got this thing. So the straight line also goes from this. As the slope is positive, meaning the straight line will be leaning like this. Why? Because the slope is positive. If it was negative, it would be like this. Making sense what we're saying? It's positive, so it goes like this. If it is negative, it goes like it might go like that. Now, what do you have? I mean, what you need to have a look at it is the slope. What is slope? The slope is 2. So, okay, let me label it with our Cartesian plane. Cartesian plane. Now, okay. So 6 is there. This is 0,6 here. So the y-intercept. Next thing that we need to look at the slope. Slope is what? A rate of change. How much you go into the y-axis as you go 1 unit on the x-axis. Okay? This is what we're going to do. This is what we're going to do. Where you go into the y-axis, let's make it a little bigger, way more bigger than this. It's perfect. So where you go onto the y-axis as you go on the x-axis. So the slope says, if you move 1 unit onto the x-axis, let's suppose here 1 unit from there to there, then you have to move 2 units on the y-axis. This is what the slope is, rate of change. So how much you move onto the y-axis if you move 1 unit on the x-axis. Meaning one of the points will be here, okay? One of the points will be here, okay? Okay, and you could do it, on the bottom also. If you go downward, let's say, 1 unit downward, then you have to move 2 units downward on. Okay, if you move 1 unit on the x-axis to the left, then you have to move 2 units onto the left. Okay. 1, 2 units there, 1 unit there. Okay, so it will look something like this. So line passes through these points. Okay. The line passes through these points, and where it cuts on the y-axis, if you want to compute where it cuts on the x-axis, where its x-intercept is, then what you can do is make this equal to 0. Make this thing equal to 0. Why do you have to make this thing equal to 0 is? Because whenever it cuts the x-axis, the y will be 0. The y the y coordinate will be 0 because it is sitting at the x-axis, meaning it is moving nowhere on the y-axis. It is at 0. So make this equal to 0. So you have 2x plus 6 is equal to 0 because the output should be 0. The y should be 0 to cut the x. Excuse me, to cut the x-axis. So if you compute it, you're going to have x is minus 3. So 1 and 1, 2, 3. So it should have been there, but as I'm not doing it perfectly. Okay, I have a little mismatch there. Why? Because the scales are not perfect. So 1, 2. Let's say this is 3. It should cut this like this. Okay, it should. Okay, so if you do it perfectly on a graph paper, then it will look perfectly in this straight. Okay, it will look perfectly straight. So it's minus 3 onto the x-axis. Get what I'm doing? So this is how I draw the graphs. You can also do it by by putting in different points there. If you put in 0, what do you get as its output? If you put 1 into it, what do you get as its output? Note them down, and then I can plot it on the XY plane. That is another way also to do it.